Alright, in this video I'm going to show you how to find any trig value that you want if you were given a point on the terminal side of the angle. So in this case we're given that the point -4, 2 lies on the terminal side of this angle. So I recommend drawing yourself a little sketch. So let's see. The point -4, 2 let's say it would be about right here. So -4, 2. So this is going to be on the terminal side of some angle, theta. Okay, now even though the angle theta really goes like this, okay, this would be the angle theta, we're going to actually wind up using this angle in here. But you're going to see that it's still going to wind up giving us the correct answers as long as when we draw our picture we use the correct signs. So I'll show you how. Okay, alright, so you need to draw a triangle like this. Alright, drop a perpendicular to the x-axis. Now look at these numbers. So -4 is the x value, so this point is 4 to the left. So rather than just putting 4 as the length of this triangle, I'm going to put -4, and that's what's going to allow me to look at this angle, but it's because I'm using -4, it's still going to actually give me the right answer for theta. And so this 2, the y value, that's the height of this point. So I'm going to put that +2 right here. Now in terms of this triangle, we have a hypotenuse, okay, running from here to here. And we're going to need that in order to do our trig functions. So I see the Pythagorean theorem in our future. So I'm going to call this hypotenuse h. So according to the Pythagorean theorem, 2 squared plus 4 squared will equal h squared. So that's going to give us 4 plus 16 is equal to h squared. So that's 20 is equal to h squared. So that's the square root of 20 is equal to h. Alright, now let me simplify that a little bit. So h is the square root of 20. But remember, the square root of 20 is the square root of 4 times the square root of 5. So h is actually 2 radical 5. So I'm going to record it that way. So that's the hypotenuse, is 2 radical 5. So now let's talk about the sine and the secant. Well, the sine is going to be the easiest one. Alright, we know that sine is opposite over hypotenuse. So that would be 2 over 2 radical 5. Now notice that these 2's are going to cancel each other out. So you really want to reduce things as far as possible. So if these 2's cancel each other out, then that's going to wind up giving you 1 over radical 5. Alright, so I would accept this. However, if you wanted to rationalize the denominator, you'd have to multiply the numerator and denominator by radical 5, and that would give you radical 5 over 5. So I would accept either one of these answers. Now secant. What is secant? Well, secant is the reciprocal of the cosine function. So I would start by asking yourself, what is the cosine? Okay, so let's see. So cosine theta, that would be adjacent over hypotenuse, right? So that would be -4 over 2 radical 5. So that means secant is going to be the reciprocal of this. So that's going to be 2 radical 5 over -4. So let's reduce this a bit. 2 goes into 4 twice. So this would reduce to negative radical 5 over 2. Alright, so that's the best answer that you should put for secant with everything reduced down. Okay, number 4 is very similar. Suppose theta is an angle in standard position whose terminal side is in quadrant 4. So again, we should draw ourselves a little sketch. So they're telling us that the quadrant is quadrant 4. Okay, and this is quadrant 4 over here. So let's just draw ourselves an angle where the terminal side is stretching into quadrant 4. Now, they're telling us that the cosine of this angle is 12 over 13. Now again, even though the actual angle theta in standard position must go like this, alright, we can go ahead and use the reference angle as long as we're careful about the signs. So cosine is adjacent over hypotenuse. So when I draw my triangle, I'm going to use 12 as my adjacent leg, and I'm going to use 13 as my hypotenuse. So let's go ahead and draw a triangle. Alright, like you really could put this dot anywhere, it doesn't matter, but just draw perpendicular to the x-axis. So I'm going to be looking at this angle right here, the reference angle, okay, as my the angle from which I'm looking when I say adjacent. So so here is the adjacent leg. Now I have to ask myself, should it be positive or negative? Because it is to the right, I'm going to put a positive 12. If it had been to the left, I would have put negative 12. Now the hypotenuse, this sort of radius, is always going to be positive. You never put a negative hypotenuse no matter what. So anyway, that 13 is going to go right there. Now we just need to find this other side. Now this is one of the common triples. Alright, this is there's a such thing as a 5, 12, 13 triangle, so it's one of the ones I've memorized. So I know that this is going to be 5. Now if you have not memorized that, then you would just use your Pythagorean theorem real quick. So y squared plus 12 squared is equal to 13 squared. So y squared plus 144 is equal to 169. Y squared is equal to 25. So therefore y is equal to 5 once you take the square root. Okay, great. So we just found out that this y is equal to 5, like I was saying. Now, should this be a positive 5 or a negative 5, considering its position in the triangle? This should be a negative 5 because this point is down 5. Alright, this is like a y value. This is down 5. In fact, let me just make a little space so I can exaggerate this negative sign. We have a negative 5 here. So that's important. That's what allows us to get the right answer even though we're using the reference angle. You have to use the correct signs. For if it's down, it's negative. If it's to the left, it's negative. Anyway, so now we should be able to find any trig value that we want. Cotangent. Cotangent is the reciprocal of tangent. And we know that tangent is opposite over adjacent. So tangent would be negative 5 over 12. That means cotangent is going to be the reciprocal of that. So cotangent will be negative 12 over 5. Alright, problem number 5 again is very similar. The sine of some angle D is 7 over 25. Find the exact value of the remaining trig functions for the acute angle. So they're letting us off the hook. By saying it's an acute angle, that means we can just use the reference angle. So sine, the definition of sine is opposite over hypotenuse. Okay, so basically because they're saying it's an acute angle, we can just draw the picture in the first quadrant with no worries. Okay, so let's just draw our triangle like this and use this angle right here. So opposite over hypotenuse, so this would be 7, the opposite, and the hypotenuse is 25. So that means we just have to find the x value. So Pythagorean theorem again, so x squared plus 7 squared is equal to 25 squared. So x squared plus 49 is equal to 625. Alright, subtracting 49 from both sides gives us x squared is equal to 576. Taking the square root of both sides, alright, the square root of 576. Okay, so x is 24. Okay, so we just found that x was 24. So I'm going to go ahead and put that in. Alright, now that we have all the sides of this triangle, we should be able to find any trig value we want. So I'm going to go ahead and, they told us that the sine was 7 over 25. And there's this gap here, but I'm going to write it in anyway. Alright, so sine of angle D was 7 over 25. Okay, opposite over hypotenuse. The cosine is adjacent over hypotenuse. That's 24 over 25. The tangent is opposite over adjacent, so 7 over 24. Alright, now these are the reciprocals of these. So the cosecant should be 25 over 7. The secant should be 25 over 24. And cotangent should be 24 over 7.